Okay, we're going to look at inverse functions. Okay, so an inverse function is basically a function where you're kind of working backwards. So if I've got x and I perform the f function on it, I'll get f of x. Okay, now the inverse function is when you perform a function which brings you back to the start. So if I'm at f of x and perform the inverse function, f of minus 1, that's what we term it, f of minus 1, that brings us back to x. Okay, so let's take this down. F of minus 1 of x is the inverse function to f of x. Okay, so what we're going to do is start to find some inverse functions. Now it's best explained by doing a few examples. Okay, so we're going to write the inverse function to the following. Okay, so part A, we've got a function which is f of x equals 3x plus 2. We are going to find f of minus 1x. We're going to find the inverse function. Okay, now this function tells us that whatever's in the bracket, you treble it and you add on 2. Whatever's in the bracket, you treble it and you add on 2. Okay, so we're going to find the inverse function, so that's like the working backwards function. Okay, so let's say we're going to let y equals 3x plus 2, so we're going to call f of x y. Okay, so y equals 3x plus 2. Now to get the inverse function, what we would do is change the subject of the formula here so that it's equal to x. Okay, so that's just National 5 knowledge. 3x plus 2 is equal to y. And then 3x is equal to, bring that over, y minus 2. And then x is equal to y minus 2 over 3. So the function originally is to treble it and add 2. The inverse function is to take away 2 and divide by 3. Now if you think about it, that is the inverse function. That's the working backwards function. So the function is to treble and add 2, treble and add 2. The inverse function is to take away 2 and then divide by 3. That's the working backwards. Now we're going to reintroduce the functional notation. That's with f in it. So f of minus 1 of x. So replace that y with x. It's going to be x minus 2 over 3. So the original function was 3x plus 2 and the inverse function is x minus 2 over 3. So what do we do again? We let f of x equals y. So then we've got y equals 3x plus 2. We change the subject of the formula to x. So 3x plus 2 equals y. Bring the 2 across, change its sign. Divide through by 3 gives me y minus 2 over 3. Reintroduce the functional notation. So replace the y with x's. F of minus 1 equals x minus 2 over 3. So this is easily learned with a bit of repetition. So let's go for an example B. In example B, let's go with g of x equals 5x minus 2, and we're going to find the inverse function g of minus 1 of x. Okay, so first move is to let y equals 5x minus 2. We're then going to change the subject of the formula to x, so 5x minus 2 equals y. That's simple National 5 stuff. 5x equals y plus 2. And then bring the 5 down, divide x equals y plus 2 over 5. Let's reintroduce the functional notation. So it's going to be the function plus 2, or the variable plus 2 rather, over 5. But let's reintroduce it as x plus 2 over 5. Okay, let's try another few. Example C. Example C, h of x equals x squared minus 7. And we're going to find the inverse function of x, h to the minus 1 of x. Okay, so let y equals x squared minus 7. We're going to change the subject of the formula to x. X squared minus 7 equals y, so I'll have to swap sides. Bring the 7 across, make it plus x squared equals y plus 7, take the square root, x equals the square root of y plus 7. So the inverse function then is the variable plus 7 square rooted, so the square root of x plus 7. So there's the original function, and then there is the inverse function. So think about the original function. You've got x, you square it, you take away 7. So think about the inverse function would be that you add 7 on, you take the square root, which is exactly what the inverse function shows. Let's take down an example D. G of x equals 1/2 of x minus 7. We're going to find the inverse function. Okay, so let y equals 1/2 x minus 7. Let's change that subject of the formula to x. Half x minus 7 equals y. Half x equals y plus 7. And then how do we get rid of the half there? Well, we can double both sides. And that will give me x equals 2 bracket y plus 7. X equals 2y plus 14. How did I get that? Let's just go over that again. I've got rid of the half there by multiplying both sides by 2. So times 2 divided by 2 cancels out, leaving me with 1x, and then 2 bracket y plus 7, 2y plus 14. Okay, so h of minus 1 of x equals 2x plus 14. That's the inverse function. Okay, example E. F of x equals x cubed minus 11. We're going to find the inverse function. Okay, let y equals x cubed minus 11. Let's change the subject formula to x. X cubed minus 11 equals y. X cubed equals y plus 11. And well, how do you get rid of the cube? Take the cube root, so that's the cube root of y plus 11. Okay, let's introduce the functional notation. So that's going to be the cube root of the variable plus 1. The variable is x. Cube root of x plus 11. Let's take down example F. Okay, example F. F of x equals 8 minus a half x. We're going to find the inverse function. Let y equals 8 minus half x. Okay, I need to change the subject of the formula to x. So 8 minus half x equals y. Minus a half x equals, I'll bring that 8 across, it becomes minus 8, y minus 8. And then let's change that negative to a positive. So I'm going to change all signs here and make that a half x equals, well, I'm going to change that minus 8 to a 8 and that y to a minus y. Now what did I do there? Changed all signs. When you've got an equation like minus 3 plus 8 equals 5, you can change all signs and the equation is still satisfied. Change the minus 3 to a plus 3, change the plus 8 to a minus 8, and change the 5 to a minus 5. 3 minus 8 is still minus 5. So I've done that there. I've changed that negative to a positive. I've changed that negative to a positive, and I've changed that positive to a negative. Now I've got half x equals 8 minus y. I can now get rid of the half by multiplying both sides by 2. So that will give me 1x. X is equal to 2 bracket 8 minus y. X equals 16 minus 2y. Reintroduce the functional notation. The inverse function then is going to be 16 minus 2x. Okay, example G. G of x equals the square root of x minus 13. Let's find the inverse function of g. Let y equals the square root of x minus 13. Change the subject of the formula. Square root of x minus 13 is equal to y. Square root of x is equal to y plus 13. How do you get rid of that? Root x, square both sides. X will be equal to y plus 13 all squared. Reintroduce the functional notation. And the inverse function then is the variable plus 13 all squared. Okay, so now you're going to try these ones. In each case, you're going to find the inverse function, a, b, c, d, e, f, g, h. Okay, h is a wee bit of a trickier one, but remember that it's all about changing the subject of the formula. In each case, you let the function equals y, so the first one would be y equals 5x plus 2. Change the subject of the formula to x. Once you've established the inverse function, you then bring in the function notation, you change the y variable back to x, and that will give you the inverse function, and you've got plenty of examples there to look back on if and when required.